Have you ever stopped to think about what's actually happening behind the scenes every time you stream a movie or hop on a video call? You're plugging into this massive, invisible world. In this explainer, we're going to pull back the curtain on the foundations of modern networking, the quiet revolution that literally powers everything we do online. So let's dive in.
A great way to think about our global network is like a giant planetary-scale nervous system. It's this incredibly intricate web of cables and switches connecting absolutely everything. But here's the kicker. For a long time, that system was under an insane amount of pressure, a kind of strain it was never designed for, pushed right to its breaking point by, well, us.
So, what was the culprit? What created this massive digital gridlock? And maybe more importantly, how on earth did we engineer our way out of it?
Okay, let's use an analogy. Imagine the old networks were like a city's road system, built with fixed, concrete streets. For a while, that system worked just fine, but it was totally unprepared for the absolute tidal wave of traffic that was just around the corner.
Here's the most important thing to get. The old way was all about the hardware. We're talking about physical boxes, routers, firewalls, switches, that were not only expensive, but they were a nightmare to configure and incredibly rigid. If you suddenly needed more capacity, you couldn't just, magically add a new lane. You had to physically rip up the old road and build a new one. It was slow, it was costly, and it just couldn't keep up.
So what caused this traffic explosion? Well, it wasn't just one thing. It was more like a perfect storm. A convergence of four huge technological trends that created a level of demand the old hardware-based networks just couldn't handle.
First up, big data. All of a sudden, companies weren't just storing data. They were trying to process and analyze unbelievable amounts of it in real time. This demanded a whole new level of performance and agility from the network. The old dirt roads just weren't going to cut it anymore.
Second, the massive, and I mean massive, shift to cloud computing. Suddenly, our apps and our data weren't in a server room down the hall. They were in these huge, distributed data centers all over the world. This created these really complex, dynamic traffic patterns that the old rigid networks had no way of managing.
And then you've got the Internet of Things, or IoT. Billions, with a B, of new devices came online. Everything from tiny sensors in factories to the smart speaker in your kitchen. All of them started generating this constant, massive flood of data that had to be managed safely and efficiently.
And finally, the device that's probably in your hand right now, the explosion of mobile. Smartphones, tablets, and the whole bring-your-own-device trend at work meant that we all expected seamless, super-fast access from literally anywhere. And this put a totally unique kind of strain on both the wired and wireless parts of the network.
All right, so the problem was crystal clear. We were in a digital traffic jam of epic proportions. So, what was part one of the solution? Pure, unadulterated power. We had to build bigger, faster digital highways. This was the brawn part of the networking revolution.
And what's really amazing is just how dramatic this leap in speed has been. Just take a look at this chart. It does a fantastic job of showing the exponential growth in speed for both wired Ethernet and Wi-Fi. We are not talking about small little improvements here. This was a complete and total paradigm shift in raw capacity.
Let's really put this into perspective. Back in 1983, the standard for Ethernet was 10 megabits per second. By 1998, we hit 1 gigabit. That's 100 times faster. But then, just 12 years later, we hit 100 gigabits per second. That is a 10,000-fold increase in under 30 years. The acceleration is it's mind-boggling.
Hey, this wasn't just happening with wires plugged into the wall. Wireless technology caught up in a huge way. Modern Wi-Fi products today can hit speeds approaching 7 gigabytes per second. Think about that. That's faster than what a high-end wired connection could get you just a few years back. But speed isn't everything, right? A 10-lane highway is still going to have traffic jams if you don't have a smart traffic control system. So the network also needed intelligence. It needed flexibility. This was the brains of the operation. So, how did we build a smarter network? The first huge innovation was something called Software-Defined Networking, or SDN, and this was a total game changer. The basic idea is to separate the network's brain, its control plane, from its body, the data plane that actually moves the bits around. This lets a central piece of software act like an air traffic controller for all your data. So imagine millions of people suddenly stream a live event. An SDN controller can see that surge and, in real time, reroute less important traffic to make sure the video stream stays perfectly smooth. You just couldn't do that with the old, rigid hardware.
Now, the second piece of this puzzle is Network Functions Virtualization, or NFV. This sounds complicated, but the concept is actually brilliant. It's about taking jobs that used to require those expensive, specialized hardware boxes, like a firewall or a load balancer, and turning them into software that can run on any standard off-the-shelf server. This means you can launch a brand new firewall just by deploying some code, and you can do it in minutes instead of waiting weeks for a physical box to show up.
So let's just put it all together side by side. The old way was rigid, it was all about hardware, it was complex, and it was painfully slow to change. The new way, powered by SDN and NFV, is flexible, it's software-centric, and it's all controlled from one central place. But the real insight here is that this isn't just an upgrade, it's a fundamental change in philosophy. We stopped treating the network like it was plumbing set in concrete and started treating it like a dynamic, programmable fabric that we can reshape almost instantly.
So you take that raw speed and you combine it with this incredible new intelligence. And what do you get? You get a completely new era of networking. And this isn't some abstract techie concept. It is the very foundation that powers the digital reality that we all live in today.
And this right here, this is the result. It's the seamless, connected ecosystem where we, the end users, can get to a whole world of apps and content and services from literally anywhere. This whole modern picture is only possible because we completely rebuilt the network's foundation with both speed and smarts.
So why does any of this matter to you? Well, it's because this new networking era is what enables the cloud services you use every single day. It's what powers the Internet of Things. It is the reason you can stream a 4K movie on your phone without it even stuttering. It's even created brand new career paths in the tech world, like DevOps, which kind of merges software development with network operations.
And all of this brings us to one last really fascinating question. For the very first time, our digital infrastructure isn't this rigid limitation anymore. It's a flexible, programmable fabric. So now that our digital roads can be completely reshaped, instantly, with just a few lines of code, where are they going to take us next? What incredible new things will this powerful foundation make possible?